Okay, so as we proceed moving forward, perhaps if looking at the top of page 305, if that type of a diagram maybe helps, to me, that just maybe makes things a lot more confusing when I look at something like that. It's actually solving the types of problems is how I feel more comfortable passing that information on to yourselves. Like for instance, I think it would be hard to describe how much fun Kansas City was having yesterday on one of their drives where they scored a touchdown but it got called back for holding. Shoot, I don't know why I was looking at you. It's Alex that's the Kansas. You're not Kansas City. Okay. But if you would follow football, it's where in the huddle they were going around in a circle, then they broke their huddle and then started going to their associated spots. That's what I mean. It's probably hard for me to describe that and maybe hard for you to visualize it, but maybe once you solve the problem and look at it, it maybe makes a little more sense. You could do the same thing on page 306, where now we're going to continue on. Rather than a two-step problem, we're moving on to three-step problems, okay? So we had done the two practice problems on page 306, which were just two steps. Now we'll move on to three steps. There is a sample problem that starts on page 306, and then continues on to 307, and then there's another sample problem. But what we see happening in there, we're going one step further. We're starting in moles and going to convert them to a type of mass in a problem. Okay, I guess that's just where I saw it had started. I thought there was some practice problems on there, but there isn't. But on top of 308, there is. Okay. Do you have a preference, one or the other on the top for practice problems, or both? Or neither? I heard both, I thought, over here. Okay. Okay, so when magnesium burns in air, it combines with oxygen to form magnesium oxide according to the following equation. Okay, so how nice was it of them to give you that reaction? Okay, so it says we've got some magnesium. Okay. We're combining that with some oxygen, and then they give this to you that it's magnesium oxide. Okay? So even if you weren't looking at that problem, how do we need to finish balancing that? Okay? We've got two oxygens here because it's diatomic. We only have one there, so we have to put a 2 here. Distribute that through. Now we have to have 2 moles of magnesium here. Okay, so that's what they have in your equation then as well. So, do you want to try this on your own or work on it together? Okay. Well, answer is 80.6, so you got the answer. Knock it out. Not much help? Probably not. Okay, so what mass in grams of magnesium oxide is produced from 2 moles of magnesium? So the only place that we can start is we have 2 moles of this substance. Okay, so how much magnesium oxide can we produce? Well, that's what we're going to move on and solve. Okay, so in your first step, how do we start this problem? So in one place. Okay, so for 2 moles of magnesium, we want to get from this substance, and just so happens all the way over to the product side and over to this substance. One of the things that we're going to see happening is even if you had skipped a step, you're still going to get the right answer, just because we've got a 2-to-2 ratio here. We'll show you what we mean here. Okay, so we're starting with 2 moles. but we're not concerned with magnesium. We want magnesium oxide. So in this next step, how do we change what it is that we have into what it is that we're looking for? Okay, so moles of magnesium down here, moles of magnesium oxide up top. Okay, so every time we see a mole over a mole, why is that important? Well, it does, but how did you know it cancels it out? I'm interpreting something differently with what you said. Okay. You're saying these have canceled each other out, correct? But what else has canceled each other out? Okay, because we've got 2 moles there, and then right. That's what I was interpreting. That I thought you meant that those were canceling each other out. Okay. So then this allowed us to change what we have into what it is that we're looking for. So now how do we get rid of this moles of magnesium oxide? Okay. So for every mole of magnesium oxide, what do we put up here? Do you think? Yep, that is correct. Oh, geez, I butchered that. Okay. There, that's better. So we just don't write any number in there. How do we know how much magnesium oxide to put in there? A little more specific. So if we're looking for grams of this substance, okay, we've got 16 of oxygen, and then what's magnesium? 24, maybe? Okay. Okay, so then that number goes here. So these two have canceled each other out as well. So 2 times 40.31 gives you 80.26. Okay, 62 grams of magnesium oxide. Okay, so whenever it is you're approaching any one of these problems, to me, the best thing that you can do after you have got your equation, and you could say even after you've balanced it, okay, write what the problem gives you, because it says that you've got 2 moles of magnesium. But what is the mass of magnesium oxide produced? So once you've located that on your product side, well then an X amount of grams, this is what we need to produce. So we need to get from this side all the way over here. And there's going to be this repeating pattern that happens over and over. You're just going to start with a substance in either grams or moles, and you have to use a mole ratio every time in this chapter. Okay? Even with limiting reactants and percent yields, you have to have a mole ratio. Okay? But that mole ratio is the only time that you go back up to this equation. Why are we not putting a 2 there? We did here, but why are we not putting a 2 down here? Other than we're telling you not to. Because the only time you're using these coefficients is when? Yeah, when you have a mole over a mole, or a mole ratio. That is the only time you go back up to this balanced chemical reaction. Well, other than looking to see what it is that you have and what you're solving for. Okay. So I don't know. Hopefully we didn't go too fast, but we got another problem we can work on. So rut row. Okay, second row. And third row. Okay. Is because a couple of times I had to, for the second row, I started over here, so I had to go back over there, and then the third row. Why is it quiet in here? Oh, maybe they're looking at me. Sorry. Okay. Do you want to go over problem number 2?
Yes.
Okay. Is it just because it's a big equation or what? I would think so. Okay. So in practice problem number 2, what mass of glucose can be produced from a photosynthesis reaction that occurs using 10 moles of carbon dioxide? Okay. So if you remember everything about plants, they take in carbon dioxide, okay? And then they'll combine with some oxygen from the atmosphere. And then what's your glucose?
No idea.
And then I goofed. No one told me that I goofed. Okay? And then what's given off as a byproduct? Okay? So it's really nice of them. They balanced that reaction for you already. Okay? So I would be led to believe must have to have a 6 there and probably a 6 here. So that's 18. So, and the 6 there. Is that right? It's the devil's equation. See, I'm sorry. I'm just laughing at your response. Well, no one's really paying attention. What were your coefficients? Is anybody superstitious in here? Okay. Yeah, well, see, sometimes we just throw that in to see if you're paying attention. I got the freshmen pretty good, you know. We got this. Okay. We've got that. Okay. Sodium chloride, that's a salt. Potassium chloride, that's a salt. Calcium chloride, that's a salt. You beat someone up, that's a salt. And yeah.
Got him.
We told a funny. Okay. So what are you given in this equation? It says you've got 10 moles of carbon dioxide. Okay? We've got 10 moles of this substance. Okay? And it's asking for what mass of glucose? Okay? So that's this substance here. We don't know. Okay? So where's the only place that you can start in this bottom problem? Yeah, your moles of carbon dioxide, what you're given in the problem. So if we've got 10 mole of CO2, okay, can we jump straight to grams of this? No, we cannot, because the only way we can do that is if we're in moles of glucose, but we have not done that yet, okay? So how do we get rid of this mole of carbon dioxide in this second step? Just like, how do we get rid of moles of magnesium here? Put it on the bottom, correct? So what are we going to put on the bottom here? Moles of CO2, okay? And this step allows us to change what we have, which is this, into what it is that we're looking for, which is this substance. And how do we do that? With a what ratio? With a mole ratio, which means we've got moles of carbon dioxide. We can change that into what it is that we're looking for in moles of what? That's just, we know what glucose is, so I'm just writing GC rather than writing this every time. Okay, so we've got a mole ratio. what does that mean you have to do? Look back at what? What's a little, you're not wrong. What's a little better than your formula? I'm standing in the way for one. Yeah, from your equation, okay? So what do we have in front of here? We've got a 6. What do we have in front of glucose? 1. We've got 1 here. So this is our mole ratio. Those are now gone. Now we're in moles of glucose. That's not the mass. That's what we're looking for. But we can't jump straight into that yet. How do we get rid of moles of glucose? Moles of glucose on the bottom. Okay. So then what do we put up here? 72 and 12 and 96. So when you've been doing these long enough, I think you get what, about 180? Okay, 180.81. 18. Okay. 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 In other words, 12 times 6 gives you 72. 16 times 6 is 96, and then 12 times 1. I mean, it's close, but it's not exact.
It's 180.18. It is.
Okay. All right. So if we've done this right, the author says we're supposed to get somewhere around 300.
How's it feel?
Okay.
How's it feel? I did that in my head. 300.
Okay. So if we take 10 times 180, well, you did that because with 1800 probably, divided by 6 gives you 300. Okay. Yep. So to the nearest tenth is what we want. Okay.
You just assigned variables that you just found. That's all you did.
Rut row.
That's how that formula works.
Second row.
You can use the same one. Everything's so fun.
Third row.
Except mole stays longer.
All right. I'll just pause this for just a moment. What we can do, all right. Do you want to work on one together while we're all here? Don't do one of them that says from the previous problem. That's not going to help. So,
Why not?
going once, going twice.
3.
Number 3. Why did you pick 3?
I don't know. You were counting down and then I picked number 3. I can do it on one hand.
Okay. Now, I'm willing to speculate on why people would rather see number 1 than number 3. No offense.
Why? 1 is easy.
But 3 is given to you already.
Yeah, the equation is giving to you number 3, but number 1 is not. Okay, so number 1. Okay, number 1. Hydrogen and oxygen react under a set of specific conditions to produce water. How many moles of hydrogen would be required to produce 5 moles of water? Okay, for the majority of these, I think these are all 2-step problems, okay, unless it's saying what is the mass from the previous problem or something to that effect. But regardless, we'll go ahead and continue. Okay, so it says hydrogen. So, now, be honest. How many of you would have forgot this if we did not work on this together? Something specific about these. Yes, both of these are diatomic. Okay. Next thing we need to do is balance that. Okay. So now you've got your equation, you've got it balanced. what is the next thing that you should do? It's kind of like in physical science. We said you've read the problem. The next thing you should do is what? Write down
What you know.
Write down what you know. Okay? So what do we know in this problem? What are we starting with? Okay? So how many moles of hydrogen would be required to produce 5 moles of water? So this, we want to know, if we have 5 moles of water is what we want, how many moles of this would be required? Okay? So, upon doing so, in this 2-step problem, how do we start it? Okay? So, we've got, I heard H2O, that's right. What about it though? We've got 5 moles of H2O. That's step 1. What is step 2? Yep, we want to get back to this side, so we got to cancel out this moles of water. So what about H2O though? And then what would go on top? Okay, we've got a mole ratio, so what does that mean? We've got these 2's here. Okay. These 2's can't just happen to cancel each other out. So 5 times 1. 5 moles of hydrogen. All right. That's all I have. We'll catch up to you next time.